Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
Hi everyone. Today's episode is sponsored by Visiopharm, Denmark-based leader in artificial intelligence-driven image analysis, tissue mining, and precision pathology. And my guest today is Jeppe Thagaard. He is Visiopharm's team lead for computer vision and artificial intelligence. With his degree in biomedical engineering, his choice to apply his technical knowledge and harness the power of machine learning to benefit healthcare was not a surprise. A personal event further narrowed his choice of where to apply his skills to the field of pathology. Today, we are going to talk about why and how AI is taking over the tissue image analysis field and if there is still space for classical image analysis methods. Listen in, and I hope you'll enjoy. How are you, Jeppe?
Good, I'm good. Thank you. Thank you for having me.
So let's start with a brief introduction. Tell the listeners about your background and what led you on this digital pathology path, because Visiopharm is on the digital pathology path.
Yeah, so my background is in medicine and technology. So I have a biomedical engineering background with 30% were on med school and then the rest of were at the technical university. So quite early, I knew that I was going to do machine learning and I wanted to do it in health. That I knew quite early on my career. And then I think at some point I was in the US and for an external stay, and I got a call from my mother saying that she had cancer, and I had been there for 3 days. And of course, as an engineer, you start looking into to what kind of information she had and all that. And that led me into kind of the pathology report. And I thought there was a lot of quantitative information there. And then that combination, together with my connection with the founders of Visiopharm, Michael Grunkin and Johan Doré, led me on the path of digital pathology.
You said that you knew that you're going to do machine learning early in your studies, but machine learning and pathology is not so old. How did you know that you wanted to do this?
Yeah, so machine learning is older than applied to pathology. Mm-hmm. And I quickly realized that there was immense power in machine learning for any problem. And I think we see that now in every field. At some point, it also struck me as that in digital pathology, there was kind of this perfect storm of untapped data, which was the requirement for machine learning. And the application needs there is very important.
Mm-hmm. Yes, I remember that in 2017 and even still 2018, AI in tissue image analysis was something very cutting edge. And fast forward 2 years, it seems to be mainstream now. How did it happen in such a short time? I mean, you say that machine learning has been there around, but not so much in pathology. At least in my experience, it was very fast.
Yeah, so I think especially the field of deep learning, that really got kickstarted in 16. Previous to the chameleon challenges, 16 and 17, there was not that many papers out there using deep learning for image analysis and pathology. I think you can almost count it on one hand, papers that used deep learning. Of course, there was a lot of papers using traditional approaches and machine learning. But you're absolutely right. Now it kind of every problem that we have, we throw deep learning after it.
Mm-hmm. So what changed in this period of time? Was it software capabilities, or was it hardware, or was it mentality of people that they adopted deep learning? Now, basically, if you speak about image analysis and you still talk about classical computer vision, people think you're old school.
Mm-hmm. Yeah, so I mean, Visiopharm is not a new company. It's founded in 2001, and since the beginning of that start, it's Visiopharm was doing image analysis and using machine learning and more traditional approaches. So what changed was this perfect storm, I think, with both the whole slide scanning were more common, getting more common, so we get more data in. But it's also the accessibility of deep learning frameworks, the software and the hardware, that definitely got more accessible to the common man, sort of say. And I think that applies to every field, not only pathology.
Mm-hmm. So we're talking about classical computer vision, classical image analysis versus AI-based image analysis methods. Let's explain what are the differences.
Okay, yeah. So the way I usually explain it is that we have this overarching field of image analysis, and there we can kind of get the computer to mimic certain tasks that a human could do. And in the simplest form, we can take the data and we can kind of understand the problem enough that we can write rules that solve the problem. And these we call rule-based systems. So that could be, for example, traditional computer image processing and then setting a threshold in a certain intensity scale, something like that. So when we go into machine learning, that's where the machine starts to learn something. And specifically, the early days of machine learning in histopathology were that we were still creating these features. We were still doing some manipulation of the image to enhance the signals of what we were looking for. But the rules from getting from that features to the output, those were learned by training data. And that could be anything like a random forest classifier, a Bayesian classifier, all these traditional machine learning approaches.
Mm-hmm.
So the kind of the latest thing is deep learning, and deep learning is basically just that we learn everything from the input data to the output data. So instead of us trying to create features or engineer features that enhance the signals that we're looking for, we simply take the raw input data. We might do some normalization of that, but then we take that and we learn both the features and the rules to get to an output. So it's just the amount in that pipeline that you actually learn from the data. That's the difference.
Mm-hmm. So we give examples now and let the system figure out what the features are instead of defining it.
Exactly. Yeah. So it's really this teach by example where we don't have to do any feature engineering. We can augment it with some feature engineering, but usually we get a long way with just inputting the raw image data.
Mm-hmm. And I know that artificial intelligence is a broader concept than just deep learning, but now it's kind of in pathology, it's kind of associated with using deep learning. So I kind of use it interchangeably here.
I think that's perfectly fine that you can do that, and that's how everybody's doing it now.
So when considering different methods for tissue image analysis, we often hear that AI is more powerful. That's why so many companies, including Visiopharm, have an AI tool, AI module, or are only doing AI. What does that mean that it's powerful? What does this power consist of?
I think there's two aspects of that. First is it can solve problems that we couldn't solve before. I think that's the key factor. So there's simply applications in pathology where we didn't knew how to write the rules in the computer to get to an output that was good enough for use. So this is the power of deep learning, that it learns these rules to a greater extent than we could program it.
So it probably means that you can work with something that you couldn't visually see and define before.
Exactly, and pathologists, they have years and years of training, and I think that was the kind of the specialty in general in medical imaging, is that these experts, medical experts, they've been trained for many years and recognizing stuff, recognizing patterns, and some of the rules that they use, the human cognition use, were just too difficult to write manually into a computer. So this is the one aspect of power, I think. I think it's the main reason why we use it. The other powerful aspect of deep learning is the way that we can approach problems. So instead we are having to spend a lot of time writing the code, we spend a lot of time collecting the data. So it's both kind of enabling another way of developing algorithms, and it also who can do that. I think that's two really important aspects of deep learning.
Mm-hmm. Do you think that code writing was narrowing who could do that, and data labeling is kind of opening it to more people? Or did we just change the profession that does the job? Because now data labeling is on pathologists. They're also a limited resource and they have limited time.
Yeah, I think that's a good point. I think it also always has been kind of this collaboration between a computer scientist and a pathologist, and I think it needs to be that, and it still is. It's just that the way that we create. So before we used 80% of the time of creating an algorithm was writing the code, experimenting with the code. And now 80% of developing is probably collecting the data, QCing it, cleaning it up, making sure that there's something that the computer can learn from. And this exercise of doing that is not only a pathologist that can do that. I think it's still a combination of a data scientist and a pathologist.
That is true. So I believe for any kind of image analysis development, you always have to work together, because there need to be a bridge between computer science and pathology. And like you said, now the weights amount of work are different. Before it was the people coding, now it's the people labeling the data. I also think that it doesn't have to be a pathologist per se labeling the data. You can train other people to do that and supervise it, so this can be leveraged.
Exactly. And that's what we also spend a lot of time on, creating software that enables both improved way of labeling, but also a different approach to labeling. So we have been working a lot with creating new ways of using immunohistochemistry or immunofluorescence to generate quantitative ground truth labeling.
This is so important. Ground truth, when it's generated by people, it's not always the same and it's not always objective. And if you have different ways of labeling that are more objective, that definitely improves the data you're working with. So, how does AI help the users of image analysis software? How does AI help the users of Visiopharm in your case?
So I think it's a little bit back to the previous topic as well. We have made the platform so it's flexible to do whatever you want to do, but we have also enabled more users to have access to more powerful computational models. And that is that maybe we can get to a really fast point with traditional image analysis, but there you had to kind of know something about image analysis, image processing. And that kept kind of a cap on who can do that, who was trained to do that. So with deep learning, we can get to a better results even faster by just kind of showing it examples. And this is exactly what broadens the user base, right? Because then people not necessarily trained in the basics of machine learning or image processing, they could get started with using deep learning for their problems. And I think that's a major breakthrough in the accessibility of this technology. So how I see it is that you can quickly get started with something with kind of minimal effort. And then what we have also done is try to make it a platform. So if you want to kind of grow your skills, you can do that in the platform as well. So if you want to you start on a basic level, you start using deep learning, then you learn more of how it works, you learn more of the concept, and there you can get more access to the underlying parameters of a neural network. And how we did it is that, of course, there's a lot of open source material on how to learn to use deep learning, but we also have our training academy that goes hand in hand, growing people into being deep learning experts in pathology, actually.
So, can anyone do AI? What are the entry requirements? You said that before it was somebody who already had knowledge of image analysis to use the software. Now it can be anyone. Really, anyone?
I think the entry level is everyone. Yeah, I think if you know what to look for and how what questions you need to ask, and you can label stuff, you can actually get 80 or 90% of the way.
So, labeling stuff, we talk about annotations, right?
Yeah.
And for different classes that we want to detect. And this is now enabled in the software in this AI module.
Yes.
So, what was Visiopharm's journey to incorporating AI into the offering?
Yeah. So it happens at one point where we I've been working with deep learning kind of on a research field outside the platform, but we saw the potential of what it could do if we needed to scale this up to more users and also internally. So I could tell that my table was very full with requests on new algorithms. So we said, all right, if we need to make all these algorithms, we need to have more people doing it. And one way of doing that is making it easier to use. And that kind of kickstarted the platform development on the deep learning module. And what we then decided was not to create something separate from the existing platform. As I said, Visiopharm has been a company for 20 years, been doing digital pathology for 20 years. So we had a lot of experience with how to handle images, how to pre-process images, how to do post-processing as well. So we kind of said, all right, where does deep learning fit into this framework? So we incorporated into the stomach of the entire platform. So you still have access to all the things that you actually need to get to an algorithm. And then you have this powerful tool in there that is deep learning.
So the modules that are classical image analysis based are staying, and this is made into an ecosystem that can play together, if I understand correctly.
Exactly. So you can kind of more maybe for advanced users can combine it with traditional approaches. But any digital pathology problem that we need to create an algorithm for actually goes kind of a fixed set of phases. So we need to, of course, extract the image from the whole slide. We need to read the whole slide first. That's also a major aspect of digital pathology.
Mm-hmm.
We need to pre-process it in some way so we can put it into a classifier, a neural network. But the neural network also gives us an output. And that output we can handle in multiple ways. So we call that post-processing, where you infer a lot of kind of object logic to your algorithm. And then you have kind of, in the end, you need to take those results and then quantify something. So that's getting density measures, getting cell counts, getting area-based measurement, all these kind of stuff that you want to do, spatial analysis, you still have to do in kind of combination with deep learning. So to sum that up, kind of deep learning fits in where we see that it's most powerful and it solves kind of what it's best to do.
Mm-hmm. So from what I hear, it definitely combines with all the other classical computer vision methods. You can use it to also derive features to later use just the classical computer vision methods. It's interesting because sometimes when you read about it, when you listen about AI, you think it's a standalone thing that you either do classical or you do AI. And here it's definitely a combination.
Yeah. So that's also why we kept the traditional approaches in there is that not every problem requires deep learning. So if you have something that's very simple, you should also pick the simplest model for that. And our platform kind of supports that way of working. So we think that it's also always the problem that should pick the method and not the method that should pick the problem.
So you mentioned Chameleon Challenge. Did Visiopharm's team take part in the challenge?
Yeah, so we actually were doing work already in the Chameleon 16 challenge and also in the Chameleon 17 challenge.
Mm-hmm. Because you said you started working on deep learning before the challenge, and then did you do well in the challenge?
In the 17 edition, we got a fifth place.
Oh, wow. Good. Congratulations.
That was a good job.
Mm-hmm. So there was a lot of development from 16 to 17. And from what I have heard, all the winning algorithms or all the first places, first 10 places, this is all deep learning, right?
Yeah, exactly. For the recognizing what is a cancer metastasis. So that for those people who don't know, the Chameleon Challenge, they were public challenges put out to the community where we needed to detect metastasis in lymph node sections from breast cancer patients. And that's also kind of what kickstarted the clinical applications with deep learning that we have today. So we actually continue working that since and have a clinical approved algorithm for the European market.
Great. Your journey in digital pathology started with a personal event with your mother being sick, and this is where it started. Now, how many years forward? 6 years forward. Where do you think it's gonna go, AI? What is it gonna give us that we don't have yet? Or are we at the end of the journey? Maybe that's it. How do you see the development of the field?
So AI in general or AI in digital pathology?
In digital pathology.
Yeah, so I think we're first getting started with using AI in digital pathology. I think there's so many low-hanging fruits that we can use or can tackle with deep learning. So three major topics is of course predictive markers. So using deep learning to predict who needs what treatment, and couple that with the companion diagnostics. I think that's going to be a major breakthrough going forward. I think we're already there with HER2, we are getting there with PD-L1, but as more and more biomarkers comes out as companion diagnostics for targeted drugs, I think deep learning plays a major role in digital pathology there. Second one is prognostics. So simply just analyzing a slide, either it's an H&E or also using immune markers to quantify the patients and make a prognosis based on quantitative data. And then the final thing is workflow optimization and quality assessment of the digital pathology workflow. I think there's many tasks that we can solve with the current state of deep learning now. And so that's kind of in the near future of where we're going. On the longer term, I can see that it, and we already see this actually in the basic research, that it gives us more insight to the underlying biology and pathology of samples, that either we use high-plex immunofluorescence or we use even higher plex kind of CyTOF technology where we have 50 plex markers per cell and goes more into detail on the understanding of the biology.
Mm-hmm. In my interview with Dr. Ralph Hoos, he mentioned this as well, that those who are not digital yet will be forced to go digital because of the advances in technology.
Yeah, I think the field is getting there. Of course, there's need to be incentive to go digital. And I think AI is kind of the nail in the coffin of that incentive. It enables us to do more than we can with an analog glass line.
Mm-hmm. So you're satisfied with this method?
Yeah, with the current methods and what we can do with that?
Yes. It kind of fulfilled your expectations.
Yeah, I'm very much looking forward to the next 5 to 10 years. That's going to be very exciting in this field.
Mm-hmm. And obviously you're looking at it with your computer scientist eyes. I'm looking at it with my pathologist eyes, and I am very satisfied with this as well, with the lower barrier to entry. This is my main gain from AI. I don't have to know which features I'm looking for. I can give examples. I know what I'm looking for. Like you said, everybody who knows that what they're looking for can get started. So this is a great advantage for me, and I think for pathologists. Thank you so much for your time, for explaining this, and have a great day.
My pleasure. Thank you very much for having me.
I want to thank Visiopharm for sponsoring this episode. To learn more about their offer, please visit their website at visiopharm.com, and I will include this address in the show notes. Thank you for listening. For more great digital pathology resources, visit the Digital Pathology Consulting website and subscribe to our newsletter on digitalpathologyconsulting.com. After subscribing, you will get access to the free digital pathology crash course, which will help you start working on your digital pathology projects immediately. Talk to you in the next episode.